Hi everyone, welcome to Tech Talk Video 10, Good Glaze, Bad Glaze. We're going to go over how we know when a glaze is good to use and some of the ways to ensure that the 30 plus glazes that we have made for you work to their best. This is a good follow-on to Tech Talk videos 2 and 3, where we showed you how to make a glaze as well as what happens when you glaze wet bisqueware. As we talked about in Tech Talk 3, we have recipes that we follow to create and refresh all our glazes in our studio. These recipes not only tell us what chemicals to use in what proportions, but also tell us what consistency all the chemicals, when added to water, should appear to be, so you can use it to glaze pottery the right way. The key point being each recipe has a set of specific gravities that we must follow in order to make the glaze right. To make a glaze, we combine a series of chemicals together with water. These chemicals are made of both small and large particles. When combined together, the ideal situation would be created a viscous enough state so that the separate particles of the chemicals will suspend in the water solution perfectly instead of attract to each other and sink. With that perfect state, the glaze, when applied to the bisque pottery, would have enough water content to let itself absorb into the open pores of the clay and hold the well-distributed glaze chemicals in place while they dried out and formed that dusty layer on the surface. Eventually, if left alone for a while, the particles will gradually start settling within the glaze. Ideally, what we want is for the glaze not to harden into a solid layer at the bottom, but into a less viscous layer that can be stirred into a well-balanced glaze. A number of glazes have enough deflocculant chemicals within the recipe, such as sodium carbonate, that they stay mostly mixed, but not all do. If a glaze separates quickly and or has a tendency to form a real hardened layer at the bottom of the bucket, it is a very flocculated and poor glaze and needs to be fixed. How we fix it is by adding a chemical called the suspension agent, which stops the separation and reduces the glaze thickness. The studio uses multiple types of suspension agents, but the most common one is bentonite. We have a measuring tool that helps us get the right chemical to water ratio in our glazes called a hydrometer. We use it to make glazes as well as to check existing glazes to make sure the level stays right. Please see video 3, Making Glazes, which shows how we use the hydrometer in action. Let's take a quick look at two glazes, pre and post mix. Here's a good example of glaze separation, but not heavy settling or flocculation, thick white chino. This glaze has been sitting unused for a week. Heavier particles have settled lower. A caramel colored layer of water about a ½ inch deep has formed on top. The caramel color is due to the soluble soda ash within the watery part of the glaze. Note that soda ash is sodium carbonate, a deflocculant, and a very important part of the chino glaze for carbon trapping. The heavier chemicals have settled to layers below. Off camera, I used a drill with a mixing blade and gave this bucket a couple of good 20 to 30 second bursts. Thorough blending is key. This will distribute all the chemicals evenly to all of the glaze and make it ready for use. Not blending long enough will not do that. Now as I stick my fingers in, you can see the glaze solution is very well suspended. I can do a finger test and it covers them with a nice coat even after I flick them around a bit. Second, here's an example of a glaze with a strong suspension agent in it, cobalt blue. If you had tried to use cobalt blue a year ago, you would have noticed complete water separation at the very top and hard settling at the bottom. Now when you look at it pre-mixed, even though there's a small water layer on top, the glaze appears to be the consistency of yogurt and fairly well mixed together even after sitting out for a week or more unused. To get the glaze this way, we added a suspension agent called V-gum. Even after it is mixed up, the glaze still appears to be quite creamy. This is due to the V-gum effect. When it dries out after application, the glaze creates a perfect coat with excellent results and little runniness as you would experience for other glazes that are this thick in appearance. The berry bowl in the intro was glazed for this video. Please note that none of our glazes stay perfect in their solution over time, especially if no one uses them for a week. For even the glazes that are seemingly well mixed together should be stirred and reformed after 15 to 30 minutes of sitting in the chemicals to get the even distribution that we need. So how do we know a glaze is right? Once we mix a glaze to the right proportions and test its specific gravity, we know it is good. But there are three ways that can make a glaze come out wrong on your bisqueware. First, water can evaporate off, and as a result, the glaze will become overly thick and viscous from its norm. A classic example of this is when a glaze bucket is left unlidded over a long period of time. If the lid is placed on properly with a good seal, evaporation cannot happen even in a hot, dry climate. Second, contamination. This is when you get portions of a different glaze mixed up together, which can happen on a double dip, one glaze over another, or by putting a contaminated tool into a glaze. An easy example to see is putting an iron-based glaze, which appears red, into a non-iron-based glaze. This is why it is critical to clean any tool thoroughly before you use it to mix a glaze. With double dips, it is ideal the first glaze to be completely dry before dipping into that second glaze. If you by accident contaminate one glaze with another, attempt to scoop off the surface where the contamination resides. If you are reluctant to do so, please ask a tech for help. The third way is if a glaze separates into a hardened bottom. When you try to mix up glazes like that, you can get fooled into thinking your mixer is at the bottom of the pail when it really isn't. It's at the top of the hardened chemicals. If you mistakenly use it, the bisque will come out with a very thin layer on it and without all the chemicals you need to make the glaze appear the way you want it in the final kiln firing. If you find a glaze like that, immediately notify Studio Tech and they will help you. A key factor in making sure you know a glaze is completely mixed, use your whisk or drill to stir it up good. Then feel around the bucket with the tool to see if the glaze has lumps in it or you still feel thicker at the bottom than at the top. More often than you think, there are issues like that. Give it another swirl with your mixer. If you're still having issue, ask a Studio Tech for help.